Hey gentlemen, so the rest of this chapter 9 we're going to be factoring, working on factoring and then solving equations by factoring. So we're going to begin this by talking about this general idea of what the point of factoring and how we'd solve these polynomial equations is called the zero product rule. Okay, so the zero product rule tells me that if we have a times b equals 0, then either a has to equal 0 or b has to equal 0. Okay, because 0 times anything is going to be 0. So this very, very quick example here illustrates this. If we've got x times x minus 2 times x plus 6 equals 0, that means that either 1, 2, or 3 of those things has to be equal to 0. So that means we're basically going to create three equations out of this. Either the first one, x is equal to 0, or x minus 2 is equal to 0, or x plus 6 equals 0. Okay, and that's the case because we need one of those three things to be equal to 0 when they're multiplied together in order for the whole thing to be equal to 0. So this first one is already done. Alright, the second one we need to add 2 to both sides to solve for x. So x equals 2. And this third one we have to subtract 6 from both sides. So x equals negative 6. So there are three possible answers for x. Alright, so if x equals 0, 2, or negative 6, then this whole equation is going to be equal to 0. Alright? So this thing called factoring is what kind of helps us get us to something that looks like this, where we can use the zero product rule. Right? Factoring is basically taking out the greatest common factor, right, from all of our terms. And another word for taking out, I like to call it undistributing. Okay, because we all know how to distribute something when we multiply. Basically, factoring is going to be undistributing it, and then we all know what the greatest common factor is. It's the biggest number or variable that is included in all of our terms. So to undistribute this, basically I'm going to find what's the biggest thing that is common to both the 14mn squared and the 35n cubed. So let's start with the numbers. All right, what's the biggest number that's both a part of 14 and 35? Think about it for a second. You should come up with 7. Okay, so we're going to take a 7 out because it's common to both of them. And then we're going to do the same with the variables. Take out the biggest number that's common to both of them. So there's an m in the first one, but there's not an m in the second one, so we can't take an m out. For n's, we've got an n squared and an n cubed. So that means since both of them have two n's, we could take an n squared out. Okay. Now, the reason I call it undistributing is because what we have to write on the inside of the parentheses, whatever's left. Okay, so if we take 7 out of 14, right, we took 7 out of 14, you're going to be left with a 2. And you're also left with m, because we didn't take the m out. But we did take the n squared out, so there's nothing left in there. Right, and in the second one, when we take 7 out of 35, we're left with 5. We didn't take any m's out, but we did take 2 of the n's out, so we're still left with 1n. Alright, so that would be the final answer. And a way to check that is to distribute it. So if you distribute this back in, you would get 14mn squared plus 35n cubed as your final answer. So that's what factoring is. The last thing we're going to work with here is the vertical motion model. Okay, so h equals negative 16t squared plus vt plus s. Alright, and I'll describe, basically this is an equation that I'm going to give to you, and you're going to have to be able to use it to solve problems. So h, that variable, it means height. Okay, t is time. V is the initial velocity in which whatever the object is moving, when it takes off, what's its initial speed. And s is the original height. Okay, so if you're at the ground, right, if you shoot off, like a firework from the ground, then s, the initial height, would be 0 because you'd be at the ground, so ground equals 0. Now what this measures is it basically measures the height of something if it's going straight up in the air after t seconds. So t equals 0 is right when the object is projected upward. Okay, let's go to the examples. So we're going to start very simply by solving something that's already pretty much laid out for us. This is already factored. We've got x plus 3 times x minus 5 equals 0. Now remember I told you that either this has to be equal to 0 or this has to be equal to 0. Right? So one of those two is going to have to be equal to 0 in order for this to be true. So we split it up into two equations, x plus 3 equals 0, and x minus 5 equals 0. To the one on the left here, we subtract 3 from both sides to get x equals negative 3. And to the one on the right, we add 5 to both sides to be left with x equals 5. So those would be the two possible answers to this problem. Numbers 2 and 3, we're just going to go ahead and factor without worrying about trying to solve anything. So we're going to take whatever is common to both of these and pull it out, undistribute it out. Okay, so for number 2 here, we're going to work with the numbers first. So what's the biggest common factor between 8 and 12? Well, that's 4. And if you take the 4 out, okay, we're going to take a 4 out of both of these. Now with the variables, one's x, one's y, they don't share anything in common, so you don't have to worry about the variables. But if you take a 4 out of 8x, you're going to be left with 2x still. And if you take a 4 out of 12y, you're going to be left with 3y. So that would be the final answer. And for number 3, right, start with the numbers, 14 and 21. You factor out a 7. And since there's a y squared and a y, we can pull one of the y's out. And in the first one, you'll be left with 2 when you take the 7 out of 14. And you're still left with 1y because we took 1y out, but there's still 1 left. And our second term, you take a 7 out of 21, and you're left with 3. And that is factored. So we're going to combine these two things, right? Solving and factoring. So we got to factor first in order to solve our equations. So number 4 here, we've got 3x squared plus 18x equals 0. So we're going to factor out whatever we can. All right, so we're going to, like I said, we're undistributing. You're taking something out of both of those, whatever's common, and then you're going to see what you have left. So we could take a 3 out and an x out, and in this first one, you'll just be left with 1x, okay, because we took 1x out, there's still 1 left. And in the second term, you're just going to be left with a 6. Now, either one of these, either 3x or x plus 6 has to be equal to 0. So we split it up into two equations, 3x equals 0 or x plus 6 equals 0. You solve both of these, and x is either equal to 0 or x equals negative 6. That's solved. Same idea for number 5. The only difference with number 5 is that we have to get everything to the left side of the equation and set it equal to 0. Why do we do that? Well, because we want to set up the zero product rule. Okay, so we're going to subtract the 14s over to the left side of the equation. Okay, so we'll have 4s squared minus 14s equals 0. Now you can factor out whatever is common. So that'll tell us that we can factor out. All right, remember you're undistributing, pulling out whatever's common to both terms. Well, we could pull out a 2s, and we'll be left with a 2s in the first one, minus 7 for the second one, equals 0. Now we get to the point where we can split this up and use the zero product rule. So either 2s equals 0, which would tell us that s equals 0, or 2s minus 7 equals 0. Okay, when we got to solve that, you add the 7 over, divide by 2, and you'll be left with s equals 7 over 2, or 3.5. So our two answers for this problem are 0 and 7 over 2. Last problem. This is going to be one of those vertical motion problems. Okay, so we're talking about this dolphin. Right, dolphins in this water, jumps out of the water. Okay, and it's going to come right back down. All right, so it tells us the initial velocity is 32. Remember that initial velocity is v. And it wants to know after how many seconds did the dolphin enter the water. So remember that down here at the base, where you're leaving and entering the water, is going to be basically height equals 0. Okay, so what we need to do is we need to use this equation. We've got h equals negative 16t squared plus vt plus s. Okay, we need to fill in as much of this as we can. Well, remember, from the end of this problem, after how many seconds did the dolphin enter the water? Well, after how many seconds, that tells us that t is going to be our variable, so that's going to be the one thing that we don't substitute a number in for, because that's what we're going to be solving. Now, when the dolphin's going to enter back into the water, it tells us that we want it to be h equals 0. So we want h to be 0. We've got negative 16 t squared. We already know from here that the initial velocity v is 32. 32t. Now, s, what's the initial position, the initial height? Well, the dolphin jumps out from the water, so it jumps from this position, which is height equals 0, so s equals 0. Now we can try to solve this. Okay, so we already have the 0 by itself. We don't need the second 0 over here, so we can just leave it as negative 16t squared plus 32t. So we could pull out whatever's common of these. We could factor that side, and when you factor it, you should be able to pull out a negative 16t. Alright, so if you pull out a negative 16t in this first term, pull the negative 16 out, so you'll be left with 1. You pull 1t out, so you'll be left with just a t. And the second one, when you pull a negative 16 out of 32, alright, so basically 32 divided by negative 16, it's going to be negative 2. Right, because negative 16, a way to check that, negative 16 times negative 2 is positive 32. So we're good there. And when you take a t out, you won't have any t's left. So it's factored like this. Negative 16t times t minus 2. Then to solve this, we know that either, let me give myself some room. So either negative 16t equals 0 or t minus 2 equals 0. Okay, so we have t equals 0 or t equals 2. Now, what this formula is doing is giving us two answers, two possible answers, either t equals 0 or t equals 2. But the answer to our actual question here, it says after how many seconds after jumping out of the water does the dolphin enter back into the water? So t equals 0 is the moment that you leave the water, right? So that means that our correct answer is going to be t equals 2 seconds. That's it, guys.